In 1977, NASA launched a spacecraft and sent it straight into forever. No return, no brakes, no plan to bring it back. But what if I told you that Voyager actually reached the edge of the solar system? And what it found out there shouldn't even be possible. A strange force, a bizarre wall of particles, and then silence. Until NASA received one final message, and they've been quiet about it ever since. What did Voyager really discover? And why did scientists go pale when the data came in? You're about to find out. In the late 1970s, NASA embarked on a mission that would redefine our understanding of the solar system and eventually take humanity's message into the stars. The Voyager program, consisting of two identical spacecraft, Voyager 1 and Voyager 2, was initially designed for a relatively modest goal to explore Jupiter and Saturn. But what began as a short-term mission quickly turned into the most ambitious journey ever undertaken by a machine built by humans. Launched in 1977, both Voyager spacecraft were powered by radioisotope thermoelectric generators and packed with state-of-the-art instruments for the time, including cameras, magnetometers, plasma detectors, and cosmic ray sensors. Each was also equipped with a now iconic golden record, a time capsule containing sounds and images from Earth, meant to communicate with any extraterrestrial life that might encounter them. NASA took advantage of a rare planetary alignment that occurs only once every 176 years. This alignment allowed Voyager to use the gravity of each planet it visited to slingshot itself toward the next, a technique known as a gravity assist. This method not only saved fuel, but significantly increased the speed and range of the spacecraft. No one expected the Voyagers to last more than a few years. Yet here we are, decades later, still receiving signals weak but unmistakable from the edge of interstellar space. Voyager 1 and 2 didn't just pass by the gas giants, they revealed them in ways humanity had never seen before. Starting with Jupiter, the Voyagers sent back breathtaking images of its massive storms, including the iconic Great Red Spot, and discovered active volcanoes on its moon, Io, the first time active volcanism had been observed beyond Earth. Next came Saturn, with its dazzling rings and enigmatic moon Titan. Voyager 1 flew close enough to Titan to study its thick atmosphere, filled with nitrogen and methane, a possible hint at conditions similar to early Earth. Meanwhile, Voyager 2 took a different path, continuing on to Uranus and Neptune, the only spacecraft to ever visit those planets. At Uranus, Voyager 2 uncovered a magnetic field, tilted wildly compared to the planet's axis, and found strange, dark rings barely visible from Earth. Neptune was even more dramatic with its deep blue color, supersonic winds, and a mysterious dark storm that seemed to appear and vanish. These encounters weren't just scientifically groundbreaking, they also changed the way we imagine the outer solar system. What had once been distant, blurry dots became dynamic, fascinating worlds. The data gathered by the Voyagers fueled decades of scientific research, helping shape our theories about planetary systems both inside and outside our own. But even after completing this grand tour, the Voyagers weren't done yet. Their true journey and their most mysterious discoveries were still to come. After completing their historic flybys of the giant planets, the Voyager spacecraft were flung outward by gravitational slingshot maneuvers, propelled into interstellar space at incredible speeds. With Neptune behind them, there were no more planets to visit, just the vast, cold emptiness stretching between stars. Yet, even in this seemingly empty region, Voyager 1 and 2 continue their mission. They begin measuring cosmic rays, magnetic fields, and the density of particles in space. These readings help map the outer boundary of the Sun's influence, a mysterious zone known as the heliosphere. The heliosphere is like a giant bubble of charged particles blown by the solar wind. It protects our solar system from much of the harsh cosmic radiation of deep space. But where does this bubble end, and what lies beyond it? As Voyager 1 moved farther from the Sun, it recorded a dramatic change in particle density and magnetic fields. In August 2012, over 35 years after launch, Voyager 1 officially crossed the heliopause, the boundary where the solar wind slows to a stop and interstellar space begins. It became the first human-made object to enter interstellar space. The data it sent back was groundbreaking. Voyager detected a higher concentration of galactic cosmic rays, proving it had left the sun's protective bubble. Yet, strangely, the direction of the magnetic field didn't shift as expected. It was as if the boundary between solar and interstellar space wasn't as clear-cut as scientists once believed, but blurred, layered, and turbulent. Meanwhile, Voyager 2, taking a different path, didn't cross the heliopause until 2018, but it confirmed the findings, showing that the edge of the solar system isn't a simple line. It's a chaotic frontier, constantly shifting and interacting with the interstellar medium. For the first time in history, humanity had reached the space between stars. Before Voyager 1 and 2 ever left Earth, NASA engineers and scientists knew that these spacecraft would one day drift beyond our solar system into the great unknown, perhaps for eternity. And with the thought came a bold idea. If there's even the slightest chance that something or someone might one day find them, shouldn't we leave behind a message? This led to the creation of the now famous Golden Records. Affixed to both Voyager spacecraft, these 12-inch gold-plated copper discs were more than just technological time capsules. They were humanity's greeting to the cosmos, carefully curated by a team led by Carl Sagan. The records contain a collection of sights, sounds, music, and messages from Earth. There are greetings in 55 languages, natural sounds like thunder, bird song, and ocean waves, musical masterpieces from Beethoven to Blind Willie Johnson, and 116 images showing human anatomy, animals, cities, DNA structures, and even a woman licking an ice cream cone. There's even a printed diagram showing the location of our sun, relative to 14 pulsars in case an alien species ever tried to track us down. But the Voyager message wasn't just about content. It was about hope, about daring to imagine that humanity, so small in the cosmic scale, might one day be noticed, that our story, even in brief, could echo in the vastness of space. Of course, the odds of the Golden Records being found are vanishingly small. The spacecraft will drift alone for billions of years, long after Earth is gone. But if they're ever discovered, they carry our voice, a voice that simply says, "This is who we are." As Carl Sagan put it, the spacecraft will be encountered and the record played only if there are advanced spacefaring civilizations in interstellar space. But the launching of this ball into the cosmic ozone says something very hopeful about life on this planet. Voyager became not just a scientific mission, but a symbol of human aspiration, our desire to reach out, to be seen, to matter. As Voyager 1 drifted farther and farther from Earth, every signal it sent home became a miracle of precision and patience. Imagine this, by 2024, Voyager 1 was over 15 billion miles away. The signals it sent, traveling at the speed of light, took over 22 hours to reach us. And they were incredibly faint. We're talking a billionth of a watt. Just detecting them required NASA's most sensitive antennas and technologies. But even with all that effort, time was running out. Each spacecraft carries 3 radioisotope thermoelectric generators, small nuclear batteries, powered by the decay of plutonium-238. These provided the electricity for Voyager's instruments, heaters, and communication systems. But over time, the power has slowly faded. Instruments were shut down one by one, heaters turned off, risking the freezing of critical components. And yet, the Voyagers kept going. In 2023, Voyager 1 encountered one of its biggest technical challenges yet. Its data system began returning gibberish, unintelligible strings of code that baffled NASA's engineers. After months of detective work, they traced the issue to a corrupted memory chip, and through sheer ingenuity, NASA remotely reprogrammed the spacecraft over 15 billion miles away, rerouting data through unused memory space. It worked. Against the odds, the signal became readable again. But everyone knows, one day, the final signal will come, not with a bang, but with silence. Just nothing. A blank sky where once a spacecraft whispered across the stars. Some engineers compare it to watching an old friend slowly fade. One day, your friend will stop speaking not because they don't want to, but because they simply can't. That day hasn't come yet, but it's close. The estimated cutoff is around 2025 to 2030. When the last systems will run out of power, the spacecraft will go silent. They'll continue drifting in interstellar space, High-powered, unseen, but still out there. In a sense, the final message from Voyager won't be words or data. It will be a silence, a profound, poetic reminder that humanity once reached this far and left a whisper in the void. Once the Voyagers go silent, their story won't end, it will simply become unknowable. Voyager 1 is now traveling at over 38,000 miles per hour, and Voyager 2 isn't far behind. Both are headed into the interstellar void, the space between stars, a place colder, darker, and emptier than anything we can truly imagine. Out here, there's no sunlight, no planets, no gravitational pull to speak of, just dust, plasma, and the occasional rogue particle moving through a cosmic nothingness. The spacecraft are essentially ghosts, now silent travelers floating through eternity. It will take 40,000 years before Voyager 1 even comes close to another star, a red dwarf named Pleiades 445, in the constellation Camelopardalis. Even then, it won't be a close flyby, just a distant brush in the black. No one will be around to receive the signal. But Voyager carries a kind of backup message. Both Voyager 1 and 2 hold the golden record, a 12-inch gold-plated copper disc, encoded with images, music, sounds of Earth, and greetings in 55 languages. It's our attempt to say, we were here, we existed, this is what we looked like, this is what we loved, this is what we dreamed. It's a cosmic time capsule, drifting endlessly through the galaxy, not because we expect anyone to find it, but because we hope they might. And maybe, just maybe, one day, someone or something will. The golden record might outlast Earth itself. It could drift for billions of years, surviving long after our planet is gone, after our sun dies, after our civilization is dust. Voyager may become the last trace of humanity, not our buildings, not our internet, not our technology, but a tiny spacecraft and a golden disk, alone in the dark. And in that way, Voyager isn't just a mission, it's a monument. The Voyagers are still flying. They don't need fuel, they don't need guidance, they just drift endlessly into the unknown, to quiet witnesses of a civilization that dared to reach beyond its cradle. One day, very soon, they'll fall silent, not with a crash, not with an explosion, just silence. And then, they'll keep going. Long after we're gone, Voyager will still be there carrying a golden disc with our voice on it. If that doesn't give you chills, nothing will. And if this journey blew your mind, even a little, smash that like button, subscribe for more strange space stories, and tell me in the comments, do you think Voyager will ever be found, or will it float forever, lost in time? Because out there, forever is very real.